Welcome to my YouTube channel, A Binary of 7. Today I am going to solve the assignment number 2 of Soil Mechanics or Geotechnical Engineering-I. Okay, are you ready? Okay, let's start. So here the first question is the correct statements from the following. So he has given 3 statements. 0 less than or equal to void ratio less than or equal to infinity. Second statement, 0 less than porosity less than 100. Third statement, 0 less than or equal to degree of saturation less than or equal to 100. Okay, so we know void ratio E is equal to volume of voids divided by volume of solids. Okay, the limits for this are 0 less than E less than infinity. Okay, because it cannot be less than 0 and it should not be is equal to 0. If it is equal to 0, there is no voids at all in a soil, so it should not equal to 0. Soil means it should have voids as well as solids. Sometimes the voids portion in the soil is more than solid portion. In that case, it will be greater than 1 as well. Okay, so the limits for this are 0 and infinity. Now coming to porosity N. Porosity N is equal to volume of voids divided by total volume of soil into 100. So it is a percentage. The limits here are 0 less than N less than 100%. Okay, and coming to degree of saturation, S is equal to volume of water divided by volume of voids into 100. The limits for this is 0 less than or equal to degree of saturation less than or equal to 100. Okay, so the given statements all are correct. The answer is D. For question number 1, the answer is D. Okay, and coming to next question, he has given void ratio E is equal to 1.59. A soil sample having a void ratio 1.59 and water content W is equal to 60% means I am writing here it is a fraction, it is 0.6, and a specific gravity S is G is equal to, not S, it is G is equal to 2.65. This soil is in which state? Which state means options are partially saturation, full saturation, or under saturation, or over saturation. So to calculate, to say the state of a sample, we need to calculate degree of saturation. S is equal to Wg by E. So W is 0.6, G is equal to 2.65, E is equal to 1.59. So that is equal to, we will get S is equal to 1. S is equal to 1 means the given soil is in full saturation. Okay, if S less than 1, it is under saturation. If S greater than 1, it is over saturation. Okay, so for this question, the answer is full saturation. The option is B. And coming to third question, a soil sample has the following properties. Moisture content, that is W is equal to 16% means I am writing it is 0.16, and maximum dry density gamma D max is equal to 1.50 gram per cc, and specific gravity G is equal to 2.65, and the degree of saturation he is asked the question. Okay, we know gamma D is equal to one formula G gamma W by 1 plus E. What is gamma D? It is 1.5 he has given, and G is equal to 2.65, and gamma W is equal to 1. So that is, he has given the units for gamma D as gram per cc. That in that case, we need to consider gamma W is equal to 1 gram per cc. So 1 plus E, how much E value we will get? E is equal to 0.7. We know one more formula, degree of saturation S is equal to Wg by E. W is 0.16, G is equal to 2.65, and E is equal to 0.76. You will get it is 0.553. So that is degree of saturation S is equal to 55.3%. Answer C. Simple questions all these are. And one of the most important question. Okay, this one, fourth question, the most important question. This type of questions you can see frequently in high level exams like GATE, IES, or else engineering services examination. Okay, so put your brain here. If soil sample of 0.2 kg having volume 10 power minus 4 meter cube and dry unit weight 1600 kg per meter cube is mixed with 0.04 kg of water, the water content of the sample is. So whatever the data he has given, put it aside. Now what he asked us, water content. Water content is weight of water divided by weight of dry soil or weight of solid. That is weight of water divided by weight of dry soil or solids. Okay, so we know density of water rho W is equal to 1000 kg per meter cube. So what is density? Weight of water divided by volume of water. So generally he added 0.04 kg of water. What is the volume of this 0.04 kg water? So that is volume of 0.04 kg water is equal to, what is that weight? Weight will be 0.04 kg and density will be 1000. Okay, you will get it is 4 into 10 power minus 5 meter cube. So this is volume of 0.04 kg water. So 0.04 kg water will have volume 4 into 10 power minus 5. And he has given some more information. I'm minimizing this content. Okay. And now dry unit weight he has given. How much? It is 1600. Dry unit weight means dry weight divided by volume. Dry weight divided by volume. So volume he has given, it is 10 power minus 4. Okay, that is dry weight divided by volume is 10 power minus 4. So what is the dry weight of the sample? That is equal to 1600 into 10 power minus 4. You will get it is 0.16 kg. This is the dry weight. So that is, it may be weight of solids or dry weight of the sample. So water content means weight of water divided by weight of dry soil or weight of solids. This denominator portion we got, and in the numerator portion weight of water we need it. Weight of water is 0.04 kg added extra amount of water. Already some of the water is there. So that is already total weight of the sample is total weight of sample, that is 0.20 kg. This total weight of sample is equal to weight of dry soil, that is 0.16 plus weight of water which is already present in the soil. So how much this you will get? 0.20 minus 0.16, 0.04. So from this we can say that there are already 0.04 kg of water is there in the soil. Now again we added again 0.04 kg. So total how much water is there on the soil now? Total weight of water in soil is equal to 0.04 kg, 0.04 kg, that is 0.08. 0.04 kg we added, and already 0.04 kg already present in the sample. Total is 0.08. So 0.08. Now what is the dry weight of the sample? That will be 0.16 kg. Now what is water content? 0.08 plus 0.16. You will get it is 50%. The most logic question. Okay, generally people say like it is a 20% or 25%. You people will get the answer because from the dry weight you will get 0.16 as a dry weight, and we added 0.04. So 0.04 divided by 0.16, you will get approximately 25%. So the near answer will be 20%. So you can put the answer is 20%. Okay. Many people will not calculate the amount which already present in the sample. They will take only weight of water as 0.04 kg. This is not the most logic question is this one. Okay. So the answer will be this 50%, option B for the question number 4. And okay, coming to next question. Question number 5. A cylindrical sample of saturated clay, 7.6 centimeter height and 3.8 centimeter diameter. So that is, he has given the dimensions of the cylinder. So you can see here, this is 3.8 centimeter diameter and 7.6 centimeter height. Weighs 148.5 grams. The sample was oven dried for, so this is 24 hours. Its weight reduced by means the decrement in weight. So 20.5 grams weight has been decreased. After decreasing 20.5 grams, so that is 148.5 minus 20.5. How much? It will be 128 grams. So this is the dry weight of the sample, and the dry density and void ratio we need to calculate. That is gamma D and void ratio we need to calculate. He has given some more information. G is equal to 2.65. Okay. From the sample, if weight has been reduced, what amount has been gone, what content has gone out, that is water content has moved away by increasing the temperature. So dry density is equal to dry weight divided by volume. Divided by volume. What is the dry weight? 128 grams. That is it. This value 128 we got from 148.5 minus 20.5. That 20.5 has reduced weight in the form of, this has been evaporated in the form of water. And volume of sample is, volume of sample he has given dimensions of the cylinder. So volume I am calculating here. Pi by 4, 3.8 square into 7.6, you will get it is 86.19 centimeter cube. So that is 86.19 centimeter cube. You will get it is 1.48 gram per cc. We have calculated, that is dry density, and he asked us to calculate void ratio. So first of all, to calculate void ratio, we need to calculate water content. Water content W is equal to weight of water divided by weight of solids or dry side. Weight of water we already know, he himself given in the problem, that is 20.5, because it is a reduced weight in the form of evaporation. And the dry weight is, and the dry weight will be 128. You will get water content is equal to 0.16. And we know dry density, we know void water content. So dry density is equal to gamma D. We have gamma D is equal to G gamma W by 1 plus E. So what is gamma W? 1.48 into 2.65 into 1 divided by 1 plus E. You will get E is equal to 0.790. Okay. Without water content, we can also calculate this void ratio directly. So the answer will be 1.48. This is 1.48 and this will be 0.7. So you will get as A as the answer. Okay, this is somewhat logic question. So he has not given the sample volume directly. He given the dimensions of the cylinder in which the sample is present. So from this you will calculate, you need to calculate the volume, its volume as volume of sample. Okay, so whenever we pour certain sample, certain soil in a container, whatever will be the shape of container, Whatever be the volume of the container, the same will be the volume of the soil. So that point you need to remember. And again, next important, the most important question is small but logic is more. Okay, so many lengthy questions will have solution very simple steps, but very small questions like 1 or 2 line questions will have logic answers. Okay, so what he said, in a wet soil mass, air occupies 1/3 of its volume. Okay, and water occupies 1/5 of its volume. Void ratio of the sample is. So first of all, we'll analyze the data what he has given. Obviously, generally a soil will consist of how many phases? You already know 3-phase diagram for the soil. So the first one is it is solids. The next one it is water. The next one it is air. So obviously void ratio E is equal to volume of voids divided by volume of solids. Volume of void is equal to volume of air plus volume of water. So that is, he said air occupies 1/3. I am treating total volume. I am assuming total volume as V. Air volume, that is VA, is equal to 1/3 of total volume, and VW is equal to 1/5 of total volume, and VS is equal to pata nahi. हमको पता नहीं as of now. Okay. But total volume is V. We can calculate volume of solids is equal to, from this, volume of voids is equal to 1/3 of V plus 1/5 of V. You will get 1/3 of V plus 1/5 of V. You will get it is 8/15 V. And volume of solid is equal to total volume minus volume of voids. Total volume is V minus volume of voids is equal to 8/15 V. So you will get it is 7/15 V. So from this expression, E is equal to volume of voids will be 8/15 V. Volume of solids is equal to 7/15 E. Obviously, it will be 8/7. E is equal to 8/7. It will be 1.142. Okay. So this answer for the question number 6 is B. Okay. It is all related to volume, no mass, no weight. Okay, as the void ratio is ratio of volume of voids to volume of solids. Out of the total solids, how many voids are there on the sample? This is void ratio. And next question again, the most important question. It is a type of, that is, we will take soil from some area and we will put this soil in certain embankments, something like road constructions. The amount of volume of soil has taken from certain area will be different, and we will compact in the roads. We will get some different volume. So like how to construct this much road, how much volume of soil has to be carried away from there? Their density will be different, here density will be different, because here we compact the soil to get maximum dry density. Okay, so now coming to the question, a pill having a volume, so this is a pill I am taking, having volume V is equal to, I am taking it is V1, so 1,60,000 centimeter meter cube. It is not centimeter, it is cubic meter. CUM means it is a cubic meter, and to be constructed at a void ratio. So the void ratio here is E is equal to 0.6. And an embankment, a borrow pit has, this is a borrow pit. So the volume is, obviously we need to calculate this only. And this borrow pit has void ratio E is equal to 1.5. Okay, so that is, borrow pit has certain void ratio. To construct an embankment having void ratio 0.6, embankment volume, there at embankment we need soil 1,60,000 meter cube. That is, to fill this, how much amount of volume of soil has to be carried away from embankment? Okay, so now we have one relation, gamma D is equal to G gamma W by 1 plus E. That is equal to, gamma D is dry density or dry unit weight, that is dry weight divided by volume. So in this expression, V directly proportional to 1 plus E, right? This is an application type of a problem. It is not a direct formula oriented. So V directly proportional to 1 plus E. I want to calculate V2. V2 by V1 is equal to 1 plus E2 by 1 plus E1. Once you got this relation as V directly proportional to 1 plus E, thus the problem is remaining is simple. So 1 plus E2 is 1 plus 1.5 divided by 1 plus 0.6, and here V1 is 1,60,000. So you will get from this expression 2,50,000 meter cube. So that is embankment. From embankment, to construct an embankment of 1,60,000 at 0.6 void ratio. Here the void ratio is 0.6. We need to borrow soil from borrow pit. That borrow pit has a void ratio 1.5. So as void ratio is more, we need to get more amount of soil, more volume of soil, that is 2,50,000. To construct an embankment of volume 1,60,000, we need to get a soil having void ratio 1.5 of 2,50,000 meter cube of volume we need to get. Clear? And there are only 3 questions remaining, 8, 9, 10. So coming to question number 8, it's question related to permeability. Okay, permeability, there are 2 types of test: constant head permeability and falling head permeability. So this question is related to falling head permeability. The starting word, a falling head permeability was tested on a soil specimen having diameter. So first I am writing specimen dia is equal to 8 centimeters and height is equal to 10 centimeters. So height 10 centimeter, a stand pipe. So here I am writing stand pipe. Dia is equal to 1.1 centimeter, and water level it dropped from, so water level dropped from 60 centimeter to 45 centimeter in how much hour? 2 hours. Now the time required for water level in the stand pipe to come down to 32. From where? From 65 only. Sorry, from 60 only. So from 60 to 32 centimeter drop. So how much time I am taking? It is time t. Clear? So he has given sample dimensions, stand pipe dimensions. He asked us to calculate what is the time required to drop from 60 centimeter to 32 centimeter, and he has given some more information. It has been taken by the stand pipe in the falling head permeability test 2 hours for a drop of 60 centimeter to 45 centimeter. Now how much amount of time it will take to drop from 60 centimeter to 32 centimeter? Obviously it will be more than 2 hours. So we will, and we have one standard formula for falling head permeability method. So K is equal to 2.303 small al by capital AT log base 10 H1 by H2. Is it clear? So now by capital A, this is sample dimension. Small a, it is stand pipe, and L is the length of the sample. By keeping all this aside, now what are all the remaining two? Time and log based on H1 by H2. So one is of the numerator, one is of the denominator. Obviously we will get an information like log based on H1 by H2. Is it directly proportional to T, right? Is it clear? It is directly proportional to time. So now log, I am dividing it is in case 1, case 2. So in case 1, H1 is equal to 60 centimeter, H2 is equal to 45 centimeter, and time T1 will be 2 hours. And in case 2, H1 will be 60 centimeters, and in case 2 itself, time 2 is equal to question mark and H2 is equal to 32 centimeters. Okay. So now I'll calculate here. log based on h1 by h2 in the case 1, 60 by 45, and log based on h1 by h2, 60 by 32 will become T1 is 2 hours, T2 is, you will get, if you will solve, T2 is equal to 4.37 hours. So if you will multiply this 4.37 into 60, you will get it is in minutes, 4 hour 22.2 minutes. Very important. The answer will be A. Application type problem, this one, clear? And yeah, theoretical question. The quantity of seepage of water through soil is proportional to. So the seepage discharge, we have a formula. Q is equal to KH NF by ND, where K is equal to permeability and H is equal to head causing the flow. Head causing the flow, that is difference between upstream and downstream. Difference between upstream and downstream. And NF is equal to number of flow channels, and ND is equal to number of potential heads, potential drops. So from this expression, Q is directly proportional to K, Q is directly proportional to H. So it is directly proportional to coefficient of permeability, difference between upstream and downstream. So both A and B are the answers. This D. Clear? Very simple. The most important. So most of the exams from geotechnical concept, this is a flow net concept. So in the dams, there is a seepage from the bottom from upstream to downstream. This seepage discharge depends on the permeability through which the soil is flowing. Permeability is nothing but velocity through which the soil is flowing. Okay, so this is a very important concept. So Q is equal to KH NF by ND is the most important formula. And last question for the assignment. So in a laboratory, constant head permeability. So earlier we solved the question related to falling head permeability, but in this question it is constant head permeability. So constant head permeability. So a cylindrical sample diameter he has given. So it is 100 mm, and height he has given, it is 150 mm, subjected to an upward flow of, that is, he has given discharge Q is equal to 540 centimeter cube per minute, and head loss over the length of the sample is measured to be head loss HF is equal to 300 mm. We need to calculate K value, that is permeability in the constant head permeability. We have a direct formula. K is equal to QL divided by H into A. So here A is equal to 5 by 4, 100 by 1000. He has given diameter, no, diameter he has given it is in mm. So I am converting that mm into meters by 1000. So you will get some value. So I am substituting that directly all the values. So the Q is equal to 540. I am converting everything into meter per second because I want the units in meter per second. So it will be 10 power minus 6. 1 minute is equal to 60. I am converting centimeter cube per minute into meter cube per second. So into L, length of the sample is 150 mm. He has, that is height of the sample is L. 150 by 1000. He has given it in mm. And H is equal to head causing the flow. What is head causing flow? It is 300 by 1000, again in meter, and area pi by 4, 100 by 1000 square. Okay, so K value you will get, it is 5.73 and 10 power minus 4 meter per second. Clear? So which option will coincide? 5.73, 5.73. Yeah, option A will coincide. Clear? So in this assignment, there are some conceptual questions, there are some logic questions. Most of these type of questions you will get in GATE exam, and mostly assistant executive engineers and assistant engineers, this type of questions only they will ask. But in GATE exam, they won't ask all these direct questions. Okay, they will ask this type of questions in a tricky manner. Okay, so you can solve all the questions. If you want, if you have any doubt, just post a comment. If you want any extra subjects, post a comment, and thank you.